supposed to go?
Yeah, you can be here at school tomorrow or Friday. Put it in the grade book.
Tomorrow I have to go to a funeral. I'm not sure what time I'm leaving. Friday I should be here after school.
It looks like Friday.
All right, here we go, gang. We're going to solve this triangle.
What?
Now, what is different about this triangle? It's not a right triangle. This is a big day for us because we are now going to have to do something different than we have done up to this point. Up to this point, we have used SOHCAHTOA, Pythagorean theorem, those two things basically to solve triangles. Those do not work unless you have a 90-degree angle. Now, I think you know why the Pythagorean theorem doesn't work. The theorem says in a right triangle, so obviously if you have a right triangle it doesn't work. Why does the SOHCAHTOA work? Sine is, for example, opposite over hypotenuse. And if you don't have a 90-degree angle, then you're not going to have a hypotenuse. So we got to rethink everything we know about trigonometry in order to solve triangles that do not contain right angles. There are two tools that I need to add to your toolkit. One is called the law of sines, and we're going to talk about it today. And the other one is called the law of cosines, and we'll talk about it tomorrow. Now, the laws of sines and cosines will solve every triangle in the whole wide world. One or the other of them will solve every triangle in the whole wide world, even right triangles. So actually, if you just hang on to your laws of sines and cosines, you can forget all that other stuff. The other stuff is easier. That's why we like to use it. But the laws of sines and cosines will do everything you need. So what does the law of sines look like? The law of sines, very simply, is a proportion. It is very easily derived, extremely easily derived. I'm not going to do it because I only have 20 minutes to get through all this, but it can, that's not just a made-up thing. Somebody derived that from some other stuff. So, take a look at the picture I have. Remember that in a triangle, sides are labeled across from their angles. So this would be side B, and this would be side A. And this would be side C, but I already know what it is. Remember, we use capital letters for angles and small letters for sides. That's just what we do in trigonometry. It's what we did in chapter 4. So looking at that, tell me how we might find angle C, side A, and side B. Those are the missing parts of the triangle. Those are the things we need to find. Chandler?
For angle C, just add the two angles together and subtract it from the
Yeah, we don't even need trigonometry to find angle C, right? We know the angles of a triangle add up to 180. So we get 85. Now, where do I go from here? What do you want to do now to solve for the sides? Now we can set up individual proportions to solve one at a time. So we want to start with right here, sine 85 over 10 equals, I don't know, sine 37 over B. It doesn't matter whether you find B or A first. You just have to pick one of them. Okay? How do I solve something that looks like that? Remember, I'm going to hit B by itself. I cross multiply. So B sine 85 equals 10 sine 37. So B ends up equaling 10 sine 37 over sine 85. So then I just go to my calculator. Please be careful. Make sure you close those parentheses. Make sure you're setting degrees. So 10 sine 37 divided by sine 85. Did you get 6.04? Oh, that was B. 6.04. Alright, and now we gotta find side A. So what do you think we'll do to find side A? Same thing. We're gonna start with this one. Please don't use this one because that's rounded off. Use the sine 85 and the 10. No round off error in those. Use sine 85 and 10, and then sine 58 over A. So we're going to cross multiply and divide.
Should it be sine? Oh, never mind.
Yeah, cross multiply and divide. And see if you come up with 8.51 as side A. Are we okay with that? Does that make sense to you? First example you've done of the law signs probably. Perfect.
How do we find angle C again?
The angles of a triangle add up to 180, and I knew two of them to start with, so the third one had to be 180 minus those two. Right? Peyton, you chewing gum?
No. Snake.
Look at this list. I gotta start writing detention. Box of Kleenex tomorrow, Peyton, full size, non-generic.
What do we have to do with
I'm
our
shaved.
names up there?
Huh?
What do we have to do with our names up there?
Strapped goes.
You have to do whatever you got down. You need a full size box of Kleenex.
I'm all shaved.
Why not generic? Why not generic?
I don't like it on my nose.
Wait, what happens if you don't?
I don't think you're shaving, are you? What's all that under your chin still?
Can't help that. It's called being grown.
All right.
No, try to.
Now, I want you to try one on your own real quick before we look at one small issue with the law signs. The law signs is very easy. I think you can see that. But there is one complication. All right, so let's say this is 39 and this is 72 and this is 15, and your job is to solve the triangle. All right, so you should be able to do this one. There's no trickiness here. This is exactly like the one we just did. We're going to look for side F, side K, and angle F. All right, so take a minute and see if you can find those three missing parts of this triangle. Okay, so everybody should be writing. You really can't do this in your head. You'll need your calculators to
69 is that? Oh, all right. Alright. I had that in my head.
that's good.
Special.
I don't know what it is.
It does not matter which order you do these proportions in. Does not matter, you have to do them both.
Gotta love Precal.
Let me know if you're not matching. If we have to talk about something, let me know. Just randomly, yeah, the hundreds is fine. All right, how does that look to everybody? Are you getting the same things I did? Law of signs, pretty easy, pretty straightforward. All right, then so no questions about this. We're good? Brayden, shut up. Are we okay here? Everybody? All right, then let's look at a potential complication. Let's look at a problem.
1-star problem. 5-star.
Where we have
half a star right now. And I was just another test.
maybe this situation. Now, what is different about this one?
There's two.
Okay, before I had a couple of different angles. Now, can I still set up my law of signs?
Yeah.
Yes, but notice, when I set up my law of signs, I am solving for an angle instead of a side, okay? When you do that, it's perfectly legit, but your little radar go up. Because potentially you might get two answers to this problem. Now, how does that work? How can I get two answers to this problem? Well, let's jump in and start solving. So we're going to do our cross multiply. No difference. We've set it up and we're solving exactly the same that we did before. Now, sine C equals 7 sine 26 over 6. Everybody okay with that? Now, when I type this into my calculator, 7 sine 26, close the parentheses, divided by 6 equals, notice, what do you get? You get a decimal, right? That decimal is not angle C. How can I find angle C? That's what I'm looking for here. What do I need to do to this decimal to get angle C? Second sign it. So second sign, second answer, and I got 30.76. So we go ahead and type this in just like we always do. But that doesn't give us the answer, it gives us the sign. So we have to second sign it. So we second sign that decimal that we got out. Alright, did everybody get 30.76? Alright, now I need you to just back up one step. You had questions on your test that looked like this. Sin x equal to decimal. 1/2. And the first thing you did was say to yourself, where could that happen? And it could happen in quadrant 1, but it could also happen in quadrant, not 3, 2. So the angle whose sine is 1/2 is 30. So you said that equation right there had two answers. One of them was 30, and one of them was 150. We did that. We did problems just like that. Now, how did you get to 150? You took 180 minus 30, right? Now, this problem was exactly the same. This said I have an angle whose sine is this decimal. One of the answers was 30.76. How would I find the other answer? The same way I did over here, which is what? How did I get the other answer? Subtracted it from 180. So what you have to figure out is, would it be possible to have a triangle with the second angle C? And the second angle C is 180 minus the first one, so it would be 149.24. So listen to me. Law of sines, super simple. It has this one little glitch. If you are using it to find an angle, you must consider the possibility of two answers. So you'll just type in your calculator regular to get the first answer. And then what will the second answer always be? 180 minus the first one. Okay? Now I keep saying you might have two answers. Is it possible in a triangle to have an angle of 26 and an angle of 149? Yes. When would it not be possible? Well, let's suppose this angle had been 46. Is it possible to have a 46 and a 149 in the same triangle? No. So that would be an example of when your second possibility isn't possible. But in our problem, the second possibility is possible. So you would not only have to finish this triangle, but you'd have to finish that one. And when I say finish it, I mean find what else is missing. What else is missing here? Both B's, right? All right, so let's go ahead and finish it. Now I want to give you another example. Oh, shoot, we don't have time to finish it. Let me give you one more. One more. We don't have time to finish that one. Let me give you one more to take a look at here. Let's suppose we had this situation. Quickly, how many triangles are possible? Well, I don't know. So I'm going to set up my law of sines.
You're on the wrong.
Pay attention, guys. You're going to be lost.
I'm already lost.
So sine C ends up being 6 sine 26.3 over 7. All right, so let's find angle C. I cross multiplied and divided. Don't forget you have to second sine. Where did you get to your angle? We aren't leaving till we get an answer to this. So you want to type this in and then second sine it. 22.32. 22.32 is that angle. Now, you immediately need to check to see if the second triangle works. You're not leaving. Sit down until I'm done. If there is a second angle, how would I find out what it is? 180 minus the first one. Always 180 minus the first one. And it would be 157.68. Now I stand back and say, can I have a 157 and a 26 in the same triangle? No, because it makes more than 180. So this is an example of a problem. All the work was exactly the same, but this one's only going to have one possible triangle, that one had 2. All right. You actually can do most of your 5-5 homework now, so you might want to get started on that. I will see you tomorrow.
If you had 2 angles, who you solved the way, could you have like 4 or 6?
No. The reason, Tomas, that we have an issue here is, remember from geometry when we did inverse postulates? We used SSS, SAS, remember all those? Okay. Well, you remember there was one combination you couldn't use because it made a bad word? You couldn't use angle side side. Okay? So when you have angle side side information, it produces this issue. Any other situation you have is going to be okay. Okay? Change your box, right? There is name on the outside of it? Yes, it is. All right, put it in the box. Thank you. Okay.
We don't know. He'd be the one that did the open loan finance and get team so. I'll miss me tomorrow.
All right, Mike said.
Yeah, Mike's doing mine and I don't know exactly.
Good luck. Gosh, just chatty with your outfit, it's like you never came back to school.
Exactly. Exactly. This is 5 months.
Like it's perfect. He came in the office and saw the back of it and I thought it was easier. Because of the look.
Yeah, you'll sit there, you'll sit there. Yeah. He always does.
You know how to make it work. Thank you.
Did I say do you want to sit in audit class?
Really? You still have wings.
What last I like 3 intense. What did you do for homework? 16 odd, that's what she said. Okay, good. Okay, I'm not the only person who did that. Well, with the amount that I skipped, I probably did the equivalent of the odds. Like, oh, I thought it was easy. I don't think I did it. I don't understand the tangent. I got the cosine and sine. Those aren't hard. The ones at the back. Okay, I love the tangent. I was fine. It said 1 through 16, but in class it said 1 through 16. You're supposed to do odd. She messed it up. No. Remember she was like, do 1 through 16 even. I was like, no, I want to do the odd. Maybe she changed her mind. Okay. 1 through 16. I don't know. It's funny, like, you change it. I did skip like 4 of them. It took me forever. It took you guys forever?
Well, they still need to practice doing problems, so that's fine.
Tangent.
But I give you my test today, so you need to be thinking along those lines.
That's probably like 60%. Yeah, that's.
I couldn't find an expert.
Like it was like something of 105. You have to figure out. Like, I don't know how you do that.
That was equals 45.
Wait, what?
That was 60 plus 45.
That makes sense. I can't think of it. I can't work with it.
Yeah, I
So I
don't
was like, I don't, like I'm looking at the numbers and I was like, I don't understand what's wrong. Good?
I question that every day. Spanish. I don't know. I feel that too. Oh, she has her glove.
Oh, I forgot we have that now.
Glove. That's not good. Yeah, I sit with her. I was like, here, take my gum.
That was